Welcome to Tech with Kaushik. This is part 10 of our complete practice question series for the SAA-C03 AWS Certified Solutions Architect Associate exam. Choose your answer before the timer ends, then review the correct answer, explanation, and exam tip. Let us begin part 10. Question number 325. Several applications connect to an Amazon RDS database. During weekend and seasonal scale-out events, the applications open large bursts of new connections and place pressure on the database. The company wants a fully managed connection pooling layer. Which solution requires the least operational overhead? Option A. Run a custom database proxy on EC2 instances and make it highly available. Option B. Deploy Amazon RDS proxy and update the applications to use the proxy endpoint. Option C. Invoke a Lambda function as a persistent connection pool for all applications. Option D. Replace the RDS database with DynamoDB solely to obtain connection pooling. The correct answer is B. Deploy Amazon RDS proxy and update the applications to use the proxy endpoint. Here's why. RDS proxy pools and reuses database connections, absorbs connection surges, and is managed and scaled by AWS. Why are the other options not correct? A. A custom proxy requires patching, capacity management, monitoring, and high availability design. C. Lambda is not a persistent shared database proxy for other application processes. D. DynamoDB is a different database model and is not a proxy for RDS. Exam tip. Use RDS proxy when rapidly scaling applications create bursts of relational database connections. Question number 326. A company is decomposing a single EC2-hosted web application. The application has static front-end assets, a PHP backend, and local REST session state. The new architecture must remove single points of failure and use managed services across multiple availability zones. Which design best meets the requirements? Option A. Serve static assets from S3 through CloudFront. Run the PHP tier as an ECS service on Fargate behind an ALB, and store sessions in a multi-availability zone Elastic Cache for REST deployment. Option B. Deploy one public Elastic Beanstalk instance that hosts both the static assets and PHP application. Option C. Run the static assets and PHP application in one Lambda function behind API Gateway and add a single REST node. Option D. Keep the PHP backend on one EC2 instance, move static files to S3, and add a multi-availability zone REST cluster. The correct answer is A. Serve static assets from S3 through CloudFront. Run the PHP tier as an ECS service on Fargate behind an ALB, and store sessions in a multi-availability zone Elastic Cache for REST deployment. Here's why. S3 and CloudFront provide managed static delivery. Fargate tasks can run across availability zones behind an ALB, and multi-availability zone REST externalizes session state from replaceable compute. Why are the other options not correct? B. One application instance remains a single point of failure. C. Lambda does not directly host static content, and this redesign introduces unnecessary application conversion and a single REST node. D. The single backend EC2 instance remains a failure point. Exam tip. For high availability, separate static delivery, stateless multi-availability zone compute, and replicated shared session state. Question number 327. A public HTTP application runs on EC2 instances in an auto-scaling target group. The endpoint must preserve load balancer sticky sessions and must be protected by an AWS WAF Web ACL. Which two actions should the solutions architect take? Choose two. Option A. Create an internet-facing application load balancer and register the existing target group. Option B. Create an internet-facing network load balancer and register the target group. Option C. Create a gateway load balancer and register the application targets. Option D. Assign elastic IP addresses to the instances and create a second target group. E. Create an AWS WAF Web ACL and associate it with the public endpoint. The correct answer is A. Create an internet-facing application load balancer and register the existing target group. E. Create an AWS WAF Web ACL and associate it with the public endpoint. Here's why. An ALB supports target group stickiness for HTTP and HTTPS applications and can be associated with an AWS WAF Web ACL. Why are the other options not correct? B. Network load balancers are not supported resources for AWS WAF association. C. Gateway load balancer is designed for network virtual appliances, not sticky web sessions. D. Elastic IP addresses and a second target group do not provide WAF protection or the required endpoint behavior. Exam tip. Use an ALB when a public web endpoint requires both AWS WAF and application layer session stickiness. Question number 328. A new AWS customer is closing a data center and must move 50 terabytes to Amazon S3 within 2 weeks. Its existing site-to-site VPN is already 90% utilized, and there is insufficient time to provision a new dedicated circuit. The company can transport its own storage devices to a secure AWS transfer location. Which service best meets the current requirement? Option A. Run AWS data sync across the existing VPN connection. Option B. Order a new AWS Direct Connect connection for the migration. Option C. Reserve an AWS data transfer terminal upload suite and transfer the data from customer-provided storage devices. Option D. Deploy AWS Storage Gateway and use it as the bulk migration mechanism. The correct answer is C. Reserve an AWS data transfer terminal upload suite and transfer the data from customer-provided storage devices. Here's why. AWS Data Transfer Terminal provides secure physical locations with high bandwidth connectivity to AWS. It avoids the saturated VPN and can support a short, high-volume migration when the customer brings storage devices. Why are the other options not correct? A. Data sync would compete for the small amount of remaining VPN bandwidth. B. A new direct connect connection is unlikely to be provisioned within the 2-week deadline. D. Storage Gateway provides hybrid storage integration, but is not the fastest solution for this constrained one-time transfer. Exam tip. For new customers with limited network capacity, evaluate Data Transfer Terminal or AWS Partner Physical Transfer Solutions instead of Snowball Edge. Question number 329. A company wants to deploy infrastructure consistently through automation and retain a complete history of incremental resource configuration changes for security audits. Which combination of services meets the requirement? Option A. Provision the infrastructure with AWS CloudFormation and record configuration changes with AWS Config. Option B. Use AWS organizations to provision application infrastructure and AWS Config to track it. Option C. Provision infrastructure with CloudFormation and use AWS Service Catalog as the configuration history system. Option D. Use AWS organizations for deployment and AWS Service Catalog for change auditing. The correct answer is A. Provision the infrastructure with AWS CloudFormation and record configuration changes with AWS Config. Here's why. CloudFormation provides repeatable infrastructure as code, while AWS Config records resource configuration history and evaluates changes for auditing. Why are the other options not correct? B. Organizations manages accounts and governance policies, not application resource provisioning. C. Service Catalog distributes approved products, but does not record all incremental configuration changes. D. Neither service combination provides the required infrastructure deployment plus configuration history capabilities. Exam tip. Use CloudFormation to provision infrastructure and AWS Config to track resource configuration changes. Question number 330. A small stateless Python website and a MySQL database currently run together on one EC2 instance. The company needs a highly available AWS architecture but cannot change application code or replace the relational database model. Which 2 actions should a solutions architect take? Choose 2. Option A. Migrate the MySQL database to an Amazon RDS for MySQL multi-availability zone DB instance. Option B. Replace MySQL with DynamoDB and enable DynamoDB auto-scaling. Option C. Use AWS DataSync to synchronize database files among multiple EC2 instances. Option D. Attach a separate internet gateway to every availability zone. E. Place EC2 application instances in an auto-scaling group across two availability zones behind an application load balancer. The correct answer is A. Migrate the MySQL database to an Amazon RDS for MySQL multi-availability zone DB instance. B. Place EC2 application instances in an auto-scaling group across two availability zones behind an application load balancer. Here's why. RDS multi-availability zone provides managed database failover without changing the MySQL interface. An ALB and a multi-availability zone auto-scaling group provide redundant, replaceable capacity for the stateless application tier. Why are the other options not correct? B. DynamoDB requires data model and application changes. C. DataSync is a file transfer service and does not provide transactional MySQL replication. D. AVPC uses one internet gateway across availability zones. Separate gateways are neither possible nor required. Exam tip. For an unchanged stateless application, combine multi-availability zone compute behind an ALB with a multi-availability zone relational database. Question number 331. A quality assurance team runs a repeatable load test against a DynamoDB table for exactly 4 hours every Saturday. The team knows the required reads and writes per second and uses no other DynamoDB workloads. Which capacity approach minimizes the table cost? Option A. By DynamoDB reserve capacity for a 3-year term. Option B. Use provision capacity and set the required read and write capacity units for the test window. Option C. Use on-demand capacity and manually specify read and write capacity units for the test window. Option D. By DynamoDB reserve capacity for a 1-year term. The correct answer is B. Use provision capacity and set the required read and write capacity units for the test window. Here's why. The throughput is known and needed only during a short weekly window. Provision capacity can be set to the measured rate for the test and reduced afterward without a long commitment. Why are the other options not correct? A. A 3-year reservation commits the company to capacity that is used only a few hours each week. C. On-demand mode does not use customer-configured read and write capacity units. D. A 1-year reservation is still excessive for a short, periodic test workload. Exam tip. Use provisioned DynamoDB capacity when throughput is predictable and can be adjusted around a known schedule. Question number 332. A digital publisher reviews AWS spending every month and recently found an unexpected cost spike. The finance team needs a managed service that learns normal spending patterns and alerts designated owners when abnormal charges occur. Which solution should be used? Option A. Create an AWS cost anomaly detection monitor and configure an alert subscription. Option B. Create a zero-spend budget from an AWS budgets template. Option C. Build current workload estimates in AWS pricing calculator. Option D. Use Amazon CloudWatch alarms to detect anomalies in consolidated billing data. The correct answer is A. Create an AWS cost anomaly detection monitor and configure an alert subscription. Here's why. Cost anomaly detection applies machine learning to actual billing data and can notify subscribed stakeholders when unusual spend exceeds a configured threshold. Why are the other options not correct? B. A zero-spend budget alerts on any charge rather than identifying deviations from normal spending patterns. C. Pricing calculator estimates architecture costs and does not monitor incurred charges. D. CloudWatch is not the purpose-built managed service for organization-wide billing anomaly detection. Exam tip. Use cost anomaly detection for unusual patterns. Use AWS budgets for fixed spending thresholds. Question number 333. A retail campaign has delivered a new batch of clickstream objects to Amazon S3. Analysts need to inspect the data immediately with SQL before deciding whether to run downstream processing. The company wants the least infrastructure administration. Which design meets the requirement? Option A. Maintain a Hive metastore and run Spark SQL jobs on an Amazon EMR cluster. Option B. Run an AWS Glue crawler to catalog the objects and query the resulting tables with Amazon Athena. Option C. Build external tables in a Spark catalog and run AWS Glue ETL jobs for each query. Option D. Catalog the objects with AWS Glue and query them by using Amazon Managed Service for Apache Flink. The correct answer is B. Run an AWS Glue crawler to catalog the objects and query the resulting tables with Amazon Athena. Here's why. The crawler discovers the S3 schema and creates data catalog metadata. Athena then performs serverless, ad hoc SQL directly against the stored objects. Why are the other options not correct? A. EMR and a Hive metastore require cluster provisioning and administration for an exploratory query. C. Glue ETL jobs add processing configuration when only interactive SQL inspection is required. D. Managed service for Apache Flink targets streaming applications, not ad hoc queries over a static S3 batch. Exam tip. Use a Glue crawler plus Athena for low-overhead SQL discovery and analysis of data already in S3. Question number 334. An engineering office uses an on-premises SMB share. Newly created design files are accessed frequently for 7 days. Older files can be archived, but users must retain the SMB workflow and must be able to retrieve archived files within 24 hours. Which architecture meets these needs? Option A. Deploy an Amazon S3 file gateway and transition objects to S3 Glacier Deep Archive after 7 days with an S3 lifecycle rule. Option B. Give every user direct Amazon S3 access and transition objects to S3 Glacier flexible retrieval after 7 days. Option C. Run AWS DataSync once per day to copy files older than 7 days to AWS without providing a gateway share. Option D. Deploy an Amazon FSx file gateway and apply an S3 lifecycle rule to its files after 7 days. The correct answer is A. Deploy an Amazon S3 file gateway and transition objects to S3 Glacier Deep Archive after 7 days with an S3 lifecycle rule. Here's why. S3 file gateway presents an SMB share, caches active files locally, and stores the objects in S3. A lifecycle rule can move older large files to Deep Archive, whose standard retrieval fits the 24-hour requirement. Why are the other options not correct? B. Direct S3 access changes the existing SMB workflow and requires user-side access changes. C. DataSync transfers data but does not preserve continuous SMB access to archived content by itself. D. FSx file gateway stores data in FSx for Windows file server, so S3 lifecycle rules do not apply. Exam tip. Use S3 file gateway to preserve SMB access while S3 lifecycle moves cold files into archive classes. Question number 335. A ticketing platform runs on an EC2 auto-scaling group and stores transactions in Amazon RDS for PostgreSQL. During popular events, repeated read queries saturate the primary database and increase response time. Which two changes should a solutions architect make? Choose 2. Option A. Move all application instances into the same availability zone as the DB instance. Option B. Create an RDS read replica and route suitable read-only queries to the replica. Option C. Convert the database to a traditional multi-availability zone deployment and direct reads to the standby. Option D. Add an Amazon Elastic Cache cluster and cache frequently requested query results. E. Enable automatic compute scaling directly on the existing RDS DB instance. The correct answer is B. Create an RDS read replica and route suitable read-only queries to the replica. D. Add an Amazon Elastic Cache cluster and cache frequently requested query results. Here's why. A read replica removes read traffic from the writer while elastic cache serves repeated results from memory. Together, they reduce database load and latency during traffic bursts. Why are the other options not correct? A. A single availability zone placement reduces resilience and does not remove the read bottleneck. C. A traditional multi-availability zone standby is for failover and does not serve application reads. E. A provisioned RDS-DB instance does not automatically scale compute in the manner described. Exam tip. For heavy relational reads, combine read replicas with caching when many queries repeat. Question number 336. A healthcare company creates daily EBS snapshots for compliance. Storage administrators must keep their current permissions, but the company needs to make selected snapshots undeletable for a defined retention period. Which solution requires the least administration? Option A. Attach an explicit deny for snapshot deletion to every storage administrator. Option B. Tag the snapshots and rely on Amazon Recycle Bin to recover them after deletion. Option C. Lock the EBS snapshots for the required period by using EBS snapshot lock. Option D. Create a separate EC2 instance and deletion role for all snapshot management operations. The correct answer is C. Lock the EBS snapshots for the required period by using EBS snapshot lock. Here's why. EBS snapshot lock protects a snapshot against deletion for a specified duration in governance or compliance mode without removing the administrator's existing permissions. Why are the other options not correct? A. An explicit deny changes the administrator's effective permissions, which violates the requirement. B. Recycle Bin supports recovery after deletion, but does not stop the deletion event from occurring. D. A dedicated instance and rollout operations and do not inherently prevent accidental deletion. Exam tip. Use EBS snapshot lock when retention requires snapshots to remain undeletable for a defined period. Question number 337. A logistics platform needs near real-time visibility into traffic metadata for network interfaces in AVPC. The records must be delivered to Amazon OpenSearch Service for investigation with minimal custom processing. Which pipeline should be implemented? Option A. Send VPC flow logs to an AWS CloudTrail trail and use Amazon Data Firehose to load OpenSearch Service. Option B. Publish VPC flow logs to CloudWatch logs and use a subscription to deliver records through Amazon Data Firehose to OpenSearch Service. Option C. Publish VPC flow logs to CloudWatch logs and use Kinesis data streams without a consumer to load OpenSearch Service. Option D. Send VPC flow logs to an AWS CloudTrail trail and stream the trail through Kinesis data streams. The correct answer is B. Publish VPC flow logs to CloudWatch logs and use a subscription to deliver records through Amazon Data Firehose to OpenSearch Service. Here's why. VPC flow logs collect network interface traffic metadata. A CloudWatch log subscription can pass the records to Amazon Data Firehose for managed, near real-time delivery to OpenSearch Service. Why are the other options not correct? A. CloudTrail is not a destination for VPC flow logs. C. Kinesis data streams requires a separate consumer application to write records to OpenSearch Service. D. CloudTrail records control plane API activity and cannot receive VPC flow logs. Exam tip. Use VPC flow logs for network metadata and Data Firehose for managed delivery to OpenSearch. Question number 338. A legal records platform stores confidential objects in Amazon S3. Security administrators must control key policies, rotation, enablement, and disabling while avoiding a custom encryption service. Which encryption design meets the requirement? Option A. Encrypt objects with SAA-C03 and use the Amazon S3 managed keys. Option B. Encrypt objects on an EC2 instance with locally managed keys before uploading them. Option C. Create a customer-managed AWS KMS key and configure the bucket to use SSCKMS with that key. Option D. Use an AWS managed KMS key for Amazon S3 and manage its rotation schedule directly. The correct answer is C. Create a customer-managed AWS KMS key and configure the bucket to use SAA-C03 with that key. Here's why. A customer-managed KMS key gives the company administrative control over policy and lifecycle settings, while Amazon S3 performs managed server-side encryption. Why are the other options not correct? A. SAA-C03 does not expose customer control over the encryption key lifecycle. B. Client-side processing on EC2 introduces custom key handling and re-encryption operations. D. AWS-managed keys have limited customer administration, and their rotation is controlled by AWS. Exam tip. Choose a customer-managed KMS key when the customer must control key policy and lifecycle. Question number 339. A backup appliance exports VM backups to Amazon S3. Every backup must remain immutable for 30 days and then be removed automatically after the retention window. Which 3 configuration steps provide the most defensible implementation? Choose 3. Option A. Enable S3 object lock on the backup bucket. Option B. Configure a default object lock retention period of 30 days. Option C. Create lifecycle rules that expire the current version after 30 days and permanently expire non-current versions after they are no longer protected. Option D. Enable S3 versioning without configuring object lock. E. Tag each object with a text value that states the retention date. F. Use only a lifecycle transition rule to protect the backups for 30 days. The correct answer is A. Enable S3 object lock on the backup bucket. B. Configure a default object lock retention period of 30 days. C. Create lifecycle rules that expire the current version after 30 days and permanently expire non-current versions after they are no longer protected. Here's why. Provisionally, object lock enforces the 30-day immutable period and default retention applies it automatically. Version-aware lifecycle expiration is also needed because current version expiration alone creates a delete marker and leaves the protected version non-current. Why are the other options not correct? D. Versioning alone preserves versions, but does not prevent authorized deletion or overwrite during the retention period. E. A tag records metadata, but does not enforce retention or deletion. F. Lifecycle rules do not provide worm protection during the required retention window. Exam tip. With object lock, design lifecycle expiration for both current and non-current versions. A delete marker alone is not permanent deletion. Question number 340. A media archive receives new objects continuously in a source S3 bucket. Each changed object must be synchronized to a second S3 bucket and to an Amazon EFS file system. Unchanged destination files must not be overwritten. Which solution has the least operational overhead? Option A. Run an EC2 synchronization host that compares the source bucket with both destinations on a schedule. Option B. Create 2 AWS data sync tasks, one for each destination, and configure each task to transfer only changed data. Option C. Invoke a Lambda function for every S3 event and implement copying, retries, and comparison logic in code. Option D. Create data sync tasks that transfer the full source dataset to both destinations on every run. The correct answer is B. Create 2 AWS data sync tasks, one for each destination, and configure each task to transfer only changed data. Here's why. Data sync provides managed recurring transfers and can compare source and destination metadata so that only changed data is copied. Separate tasks support the S3 and EFS destinations. Why are the other options not correct? A. An EC2 host requires patching, scheduling, monitoring, and custom synchronization logic. C. A Lambda pipeline requires custom handling for retries, errors, large files, and 2 destinations. D. Full transfers repeatedly consume bandwidth and overwrite unchanged data unnecessarily. Exam tip. Use one data sync task per destination and select Change Data Transfer for recurring synchronization. Question number 341. A research platform stores all EC2 data on encrypted EBS volumes. The security team must control when the encryption key rotates and wants to avoid operating external key infrastructure. Which solution is appropriate? Option A. Use an AWS-owned key for all EBS encryption. Option B. Create a customer-managed KMS key and use it to encrypt the EBS volumes. Option C. Use the AWS-managed key for EBS and configure a customer-defined rotation schedule. Option D. Import external key material into KMS and manage its expiration and re-import process. The correct answer is B. Create a customer-managed KMS key and use it to encrypt the EBS volumes. Here's why. A customer-managed KMS key supports EBS encryption and lets the company control policy, rotation, enablement, and disabling without running a separate key service. Why are the other options not correct? A. AWS-owned keys do not provide customer administration or rotation control. C. AWS controls the lifecycle of AWS-managed keys. Customers cannot define their rotation schedule. D. Imported material adds external generation, expiration, and re-import operations. Exam tip. Use a customer-managed KMS key when customer-controlled rotation is a stated requirement. Question number 342. A company must prevent new unencrypted EBS volumes and automatically detect and remediate any non-compliant volumes that appear. The solution should use managed controls and require minimal custom code. Which design meets the requirement? Option A. Use Amazon Inspector to detect unencrypted volumes and Systems Manager automation to encrypt them. Option B. Use an IAM condition to require encrypted EBS creation, an AWS config rule to detect violations, and Systems Manager automation for remediation. Option C. Use Amazon May-C to scan EBS volumes and invoke Systems Manager automation for remediation. Option D. Use KMS permissions plus a custom Lambda function and event bridge rules to detect and repair violations. The correct answer is B. Use an IAM condition to require encrypted EBS creation, an AWS config rule to detect violations, and Systems Manager automation for remediation. Here's why. The IAM control prevents non-compliant creation. AWS config continuously evaluates encryption state, and Systems Manager automation provides a managed remediation workflow. Why are the other options not correct? A. Inspector assesses software vulnerabilities and does not evaluate EBS encryption compliance. C. May-C discovers sensitive data in S3 and does not inspect EBS volume encryption. D. Custom Lambda logic adds development and maintenance when config and automation provide managed capabilities. Exam tip. Combine preventive IAM conditions with AWS config detection and managed remediation. Question number 343. A manufacturer is moving a multi-node web tier and a single MySQL server to AWS. The migration must require minimal application changes while removing the existing single points of failure. Which two actions should be taken? Choose two. Option A. Move the MySQL database to a DynamoDB table. Option B. Run the web tier on EC2 instances in a multi-availability zone auto-scaling group behind an application load balancer. Option C. Run MySQL on an EC2 auto-scaling group behind a network load balancer. Option D. Migrate the MySQL database to an Amazon RDS multi-availability zone deployment. E. Replace the web tier with an AWS Lambda function. The correct answer is B. Run the web tier on EC2 instances in a multi-availability zone auto-scaling group behind an application load balancer. D. Migrate the MySQL database to an Amazon RDS multi-availability zone deployment. Here's why. The ALB and multi-availability zone auto-scaling group provide resilient web capacity. RDS multi-availability zone retains MySQL compatibility while adding managed synchronous standby and automatic failover. Why are the other options not correct? A. DynamoDB requires a different data model and substantial application changes. C. An EC2 auto-scaling group does not safely replicate or coordinate a relational database. E. Moving the web tier to Lambda would require a major redesign rather than a minimal change migration. Exam tip. For minimal change resilience, Use multi-availability zone EC2 behind an ALB and a compatible multi-availability zone RDS deployment. Question number 344. A media company needs to host latency-sensitive applications close to a European metropolitan area. Policy prevents those workloads from running in the parent AWS region, but the company still needs VPC-connected compute with single-digit millisecond latency. Which deployment target should be selected? Option A. Extend the VPC into an AWS local zone near the users and deploy the applications there. Option B. Host the applications in CloudFront regional edge caches by extending the VPC to the caches. Option C. Extend the VPC into an AWS wavelength zone even though no carrier 5G requirement exists. Option D. Deploy in the parent region and extend the VPC into CloudFront edge locations. The correct answer is A. Extend the VPC into an AWS local zone near the users and deploy the applications there. Here's why. A local zone extends selected AWS compute and networking services from a parent region into a nearby metropolitan location and targets single-digit millisecond access for general workloads. Why are the other options not correct? B. CloudFront regional edge caches do not host general VPC application compute. C. Wavelength zones are designed for carrier 5G edge workloads, which are not required here. D. CloudFront edge locations do not extend a VPC or run arbitrary migrated applications. Exam tip. Use local zones for general-purpose VPC compute close to users. Use wavelength for carrier 5G edge cases. Question number 345. A team needs a separate EKS cluster for occasional resilience tests. The workload can tolerate interruptions, and EKS must manage the worker node lifecycle. Which node configuration minimizes cost? Option A. Create one EKS managed node group that uses only on-demand instances. Option B. Create a self-managed auto-scaling group of Spot instances and join the nodes with Bootstrap user data. Option C. Create one EKS managed node group that uses Spot instances. Option D. Create two managed node groups, keeping both on-demand and Spot capacity running. The correct answer is C. Create one EKS managed node group that uses Spot instances. Here's why. A managed Spot node group lets EKS handle provisioning and node lifecycle while using discounted interruptible capacity that fits in frequent, failure-tolerant testing. Why are the other options not correct? A. On-demand capacity costs more for an interruption-tolerant non-production cluster. B. A self-managed auto-scaling group does not meet the requirement that EKS manage all nodes. D. Maintaining an on-demand node group adds unnecessary cost for this test workload. Exam tip. Use EKS managed Spot node groups for interruption-tolerant development and test workloads. Question number 346. A university has several campuses and a growing set of AWS accounts and VPCs. Each campus must connect to the VPCs, and the number of networks will increase significantly next year. Which design provides the simplest scalable administration? Option A. Create an AWS transit gateway with VPC attachments and site-to-site VPN attachments for the campuses. Option B. Build a full mesh of VPC peering connections and separate VPN connections for every VPC. Option C. Run a self-managed VPN concentrator on one EC2 instance for all networks. Option D. Connect every campus to a central VPC with direct connect and peer that VPC to all other VPCs. The correct answer is A. Create an AWS transit gateway with VPC attachments and site-to-site VPN attachments for the campuses. Here's why. Transit Gateway provides a hub-and-spoke routing service for many VPC and hybrid attachments. Adding a new network requires an attachment rather than expanding a full mesh. Why are the other options not correct? B. A peering and VPN mesh creates rapidly increasing route and connection administration. C. One self-managed VPN appliance introduces maintenance, scaling, and availability responsibilities. D. VPC peering is non-transitive, so a central VPC does not provide scalable transit routing. Exam tip: use transit gateway when many VPC and hybrid networks need a scalable routing hub. Question number 347. A manufacturer stores several years of monthly capacity data in Amazon S3. Business analysts have no machine learning experience and need a managed, no-code workflow to train a time series model and produce monthly resource forecasts. Which two steps should they use? Choose 2. Option A. Import the historical dataset from S3 into Amazon SageMaker Canvas and create a time series forecasting model. Option B. Use SageMaker Canvas batch prediction to generate the monthly forecasts from the trained model. Option C. Write custom training code in SageMaker and deploy a real-time endpoint. Option D. Train a predictor in Amazon Forecast and invoke it from a Lambda function URL. E. Load the data into Amazon Redshift and manually implement the forecasting algorithm with SQL. The correct answer is A. Import the historical dataset from S3 into Amazon SageMaker Canvas and create a time series forecasting model. B. Use SageMaker Canvas batch prediction to generate the monthly forecasts from the trained model. Here's why. Provisionally, SageMaker Canvas provides a no-code interface for importing S3 data, building a time series forecasting model, and generating batch predictions without requiring ML development expertise. Why are the other options not correct? C. Custom SageMaker training and endpoint deployment require substantially more ML and operational expertise. D. Amazon Forecast is not available to new customers, so it is not a generally deployable current solution. E. A manually implemented SQL model does not provide the requested managed no-code training workflow. Exam tip: for new no-code forecasting workloads, use current SageMaker Canvas time series capabilities rather than Amazon Forecast. Question number 348. An organization centrally provisions AWS accounts with Control Tower and IAM Identity Center. Developers and administrators need different reusable permissions across many accounts, and newly hired staff must inherit access through team membership. Which design has the least operational overhead? Option A. Create a separate Identity Center user in every account and attach AWS managed policies to each user. Option B. Create one permission set per individual user and add extra IAM grants inside each member account. Option C. Create developer and administrator groups. Define a permission set for each team, assign the groups and permission sets to the required accounts, and add new users to the appropriate group. Option D. Attach custom IAM policies directly to Identity Center groups without using permission sets. The correct answer is C. Create developer and administrator groups. Define a permission set for each team, assign the groups and permission sets to the required accounts, and add new users to the appropriate group. Here's why. Permission sets provide reusable account access, and group assignments map the appropriate permissions to each team. New employees receive access simply by joining the correct group. Why are the other options not correct? A. Duplicating users and policies in every account defeats centralized identity management. B. Per-user permission sets and in-account grants create ongoing administration as staff changes. D. IAM Identity Center assigns IAM permissions through permission sets, not policies attached directly to groups. Exam tip: assign permission sets to groups across accounts, then manage access by group membership. Question number 349. A company wants a low-cost, standardized check that continuously identifies unencrypted EBS volumes. The company does not want to maintain scripts or compute resources for the check. Which solution should be used? Option A. Run custom describe volumes API calls in a scheduled Lambda function. Option B. Use an AWS config managed rule that evaluates whether EBS volumes are encrypted. Option C. Run a containerized encryption audit script as a recurring AWS Fargate task. Option D. Require an encryption tag and use Cost Explorer to find volumes without the tag. The correct answer is B. Use an AWS config managed rule that evaluates whether EBS volumes are encrypted. Here's why. AWS Config supplies managed compliance evaluation for EBS encryption and records non-compliant resources without custom code or always-on compute. Why are the other options not correct? A scheduled Lambda check requires code, permissions, testing, and maintenance. C. A Fargate task adds container infrastructure for a built-in compliance check. D. Tags and Cost Explorer do not verify the actual encryption state of a volume. Exam tip. Prefer AWS Config managed rules for continuous, standardized resource compliance checks. Question number 350. A video studio uploads multi-gigabyte source files from its data center to Amazon S3. A fleet of EC2 spot instances later downloads each object for transcoding. Which two techniques increase throughput for these large object transfers? Choose 2. Option A. Upload each large object by using S3 multi-part upload. Option B. Store different parts of each workload in separate S3 buckets. Option C. Download separate byte ranges of the same object in parallel. Option D. Add a randomized prefix to every object key to scale S3 requests. E. Access the bucket through an S3 access point to increase transfer bandwidth. The correct answer is A. Upload each large object by using S3 multi-part upload. C. Download separate byte ranges of the same object in parallel. Here's why. Multi-part upload sends large object parts concurrently and retries individual parts. Parallel ranged GET requests let the transcoding fleet retrieve different object segments simultaneously. Why are the other options not correct? B. S3 scales within a bucket, so additional buckets are not required for this transfer pattern. D. Randomized key prefixes are no longer required to obtain S3 request scaling. E. Access points simplify access management, but do not increase per object transfer throughput. Exam tip. Use multi-part upload for large writes and parallel range gets for large reads. Question number 351. A web fleet runs in an auto-scaling group across multiple availability zones. Editors update shared content frequently, and users must receive the new version immediately rather than stale copies. Which two storage and delivery designs meet the requirement? Choose 2. Option A. Mount a single Amazon EFS file system on every web instance. Option B. Mount one shared EBS volume on instances in multiple availability zones. Option C. Store the content in Amazon S3, set cache control to no cache, and deliver it through CloudFront so requests revalidate with the origin. Option D. Use DataSync to continuously copy local content among all EC2 instances. E. Mount separate storage gateway volume gateway ISCSI volumes on each instance. The correct answer is A. Mount a single Amazon EFS file system on every web instance. C. Store the content in Amazon S3, set cache control to no cache, and deliver it through CloudFront so requests revalidate with the origin. Here's why. EFS supplies strongly consistent shared file access across availability zones. S3 is strongly consistent, and no cache instructs CloudFront to revalidate content before serving a cached response. Why are the other options not correct? B. EBS multi-attach is zonal and cannot provide one ordinary shared volume across multiple availability zones. D. DataSync is not a real-time distributed file system coherence mechanism and can leave stale copies. E. Separate ISCSI volumes do not create one consistent shared namespace for the fleet. Exam tip. Use EFS for shared files or S3 with cache revalidation when frequently changed objects are delivered through CloudFront. Question number 352. An application is active behind application load balancers in 3 AWS regions. Route 53 must send each user to the regional endpoint that provides the best network performance. Which record configuration should be created? Option A. Create a name record that uses a failover routing policy. Option B. Create alias A records that use a latency-based routing policy. Option C. Create a records that use a geolocation routing policy. Option D. Create name records that use a geo-proximity routing policy. The correct answer is B. Create alias-A records that use a latency-based routing policy. Here's why. Latency-based routing uses AWS latency measurements to direct users to the region expected to provide the lowest latency, and alias-A records can target the ALBs. Why are the other options not correct? A. Failover routing is active-passive and does not optimize normal traffic for latency. C. Geolocation uses configured location rules rather than measured network latency. D. Geoproximity uses geographic position and bias, not the lowest measured network latency. Exam tip. Use Route 53 latency routing when normal traffic should reach the lowest latency regional endpoint. Question number 353. A web application runs in one availability zone on EC2 instances behind an ALB and stores state in a MongoDB-compatible database on those instances. The company needs multi-availability zone application availability and a managed, eventually consistent NoSQL database with minimal ongoing operations. Which solution is provisionally best? Option A. Distribute the auto-scaling group across 3 availability zones and use AWS DMS to migrate the MongoDB-compatible data to Amazon DynamoDB. Option B. Replace the ALB with an NLB and continue operating the embedded database and its replication service in one availability zone. Option C. Distribute the auto-scaling group across 3 availability zones and continue operating the embedded database on the application instances. Option D. Replace the ALB with an NLB and migrate the database to DynamoDB while keeping compute in one availability zone. The correct answer is A. Distribute the auto-scaling group across 3 availability zones and use AWS DMS to migrate the MongoDB-compatible data to Amazon DynamoDB. Here's why. Provisionally, a 3 availability zone auto-scaling group removes the compute tier zonal dependency. For a supported MongoDB-compatible source, AWS DMS can migrate data to DynamoDB, which provides managed multi-availability zone NoSQL storage and eventual reads. Why are the other options not correct? B. Changing the load balancer does not remove the single availability zone compute failure point and leaves database operations on the instances. C. Multi-availability zone compute helps availability, but operating and replicating the embedded database remains a significant burden. D. The database becomes managed, but the application tier is still confined to one availability zone. Exam tip. Confirm the source engine is supported before selecting AWS DMS. Then separate state from replaceable multi-availability zone compute. Question number 354. A retail application has a product catalog that changes monthly and a shopping cart that must survive application instance replacement and user reconnection. The platform needs very low latency and highly available cart state. Which design meets these requirements? Option A. Store catalog and cart data on one EC2 instance with EBS snapshots. Option B. Use OpenSearch service as the cache for catalog and user session data. Option C. Use Amazon Elastic Cache for RedISS to cache catalog data and maintain shared shopping cart state with replication and failover. Option D. Enable ALB sticky sessions and keep each cart only in the selected application instance. The correct answer is C. Use Amazon Elastic Cache for RedISS to cache catalog data and maintain shared shopping cart state with replication and failover. Here's why. RedISS provides low latency key value access, externalizes carts from replaceable application instances, and supports replication, persistence options, and multi-availability zone automatic failover. Why are the other options not correct? A. One instance and volume remain a single failure point, and snapshots do not provide live session availability. B. OpenSearch is designed for search and analytics rather than transient shopping cart state. D. Sticky sessions keep state tied to one target and can lose the cart when that target fails. Exam tip. Store reconnectable session and cart state in a shared, highly available RedISS deployment. Question number 355. A team is deploying interacting microservices on Amazon EKS. Operators need cluster and container metrics plus end-to-end request traces to diagnose future latency and dependency problems. Which solution meets the requirement? Option A. Enable CloudWatch container insights for EKS telemetry and instrument the microservices with AWS X-ray tracing. Option B. Use CloudTrail API event history and visualize it in Amazon QuickSight. Option C. Use AWS Trusted Advisor to trace requests between containers. Option D. Add elastic cache so fewer calls occur between the microservices. The correct answer is A. Enable CloudWatch container insights for EKS telemetry and instrument the microservices with AWS X-ray tracing. Here's why. Container Insights collects cluster, node, pod, and container telemetry, while X-ray traces requests across service boundaries and exposes latency and dependency paths. Why are the other options not correct? B. CloudTrail records AWS control plane API activity rather than application request traces. C. Trusted Advisor provides account recommendations and does not perform distributed tracing. D. Caching can change performance, but does not provide the required observability. Exam tip. Use Container Insights for EKS telemetry and X-ray for distributed request tracing. Question number 356. A SaaS provider writes each customer's process data to Amazon S3. Data must be encrypted at rest. Only a role in that customer's AWS account may decrypt it, and provider employees must be unable to decrypt it. Which design provides the strongest separation? Option A. Create one ACM private certificate per customer and use the certificates for client-side object encryption. Option B. Use a separate customer-managed KMS key for each customer and restrict each key policy so only the customer's cross-account role can decrypt that customer's objects. Option C. Use separate KMS keys but enforce KMS. Decrypt only through the S3 bucket policy. Option D. Create public ACM certificates and use certificate policies to authorize object decryption. The correct answer is B. Use a separate customer-managed KMS key for each customer and restrict each key policy so only the customer's cross-account role can decrypt that customer's objects. Here's why. Separate KMS keys create cryptographic boundaries between customers. Each key policy can authorize only the corresponding cross-account role for decryption and exclude provider employees. Why are the other options not correct? A. ACM certificates provide TLS identities and are not general-purpose S3 object encryption keys. C. An S3 bucket policy does not control the KMS decrypt operation on the KMS key. D. Public ACM certificates cannot provide object-level encryption key authorization. Exam tip. Enforce cross-account decryption boundaries in KMS key policies, not only in S3 policies. Question number 357. A security standard requires all web server EC2 instances to remain in private subnets. Internet users still need HTTP and HTTPS access to the site. Which architecture exposes the application without making the instances public? Option A. Place a NAT gateway in a private subnet and route inbound internet traffic through it. Option B. Assign a public IP address to each private subnet instance and point DNS directly to it. Option C. Deploy an internet-facing application load balancer in public subnets. Register the private instances as targets and point DNS to the ALB. Option D. Point DNS to the identifier of the auto-scaling group that contains the private instances. The correct answer is C. Deploy an internet-facing application load balancer in public subnets. Register the private instances as targets and point DNS to the ALB. Here's why. The internet-facing ALB accepts public HTTP and HTTPS traffic and forwards requests to registered targets over private VPC addresses, allowing the EC2 instances to remain private. Why are the other options not correct? A. A NAT gateway provides outbound translation, must be in a public subnet, and is not an inbound load balancer. B. A private subnet instance lacks the public routing model required by this option and violates the design intent. D. An auto-scaling group does not expose a public application endpoint or DNS target. Exam tip. Expose private web instances through an internet-facing ALB and public subnets. Question number 358. An application runs as multiple pods on Amazon EKS with AWS Fargate. The pods require persistent shared storage that remains available across availability zone failures, and the company wants minimal storage administration. Which solution should be used? Option A. Create one EBS volume and mount the same volume to every Fargate pod. Option B. Create one regional Amazon EFS file system and mount it as persistent storage for all required pods. Option C. Create separate EFS file systems in each availability zone and synchronize them with Lambda. Option D. Create multi-attach EBS volumes in each availability zone and register them in one storage class. The correct answer is B. Create one regional Amazon EFS file system and mount it as persistent storage for all required pods. Here's why. EFS provides managed, elastic, regional shared file storage and can be mounted concurrently by multiple EKS Fargate pods across availability zones. Why are the other options not correct? A. A single EBS volume is zonal and cannot provide shared, fault-tolerant storage to Fargate pods across zones. C. Multiple file systems plus custom synchronization add complexity and consistency risk. D. EBS multi-attach remains zonal and is not the appropriate shared storage model for EKS Fargate. Exam tip. Use EFS for shared persistent storage with EKS Fargate across availability zones. Question number 359. A Docker application currently stores persistent files on its local container host. The company is moving to AWS and does not want to manage container servers or storage infrastructure. Which architecture meets the requirement? Option A. Run Amazon ECS on EC2 instances and mount an EFS volume into the containers. Option B. Run Amazon ECS tasks on AWS Fargate and mount an Amazon EFS file system into the tasks. Option C. Run Amazon EKS with self-managed nodes and attach an EBS volume to one worker instance. Option D. Run Amazon ECS on Fargate and mount an S3 bucket as a standard persistent container volume. The correct answer is B. Run Amazon ECS tasks on AWS Fargate and mount an Amazon EFS file system into the tasks. Here's why. Fargate removes container host management, and EFS supplies fully managed persistent shared files that remain available as tasks are replaced or scaled. Why are the other options not correct? A. The EC2 launch type requires the company to operate container instances. C. Self-managed EKS nodes and the EC2 attached volume requires server and storage administration. D. S3 is object storage and is not configured as a normal persistent ECS file system volume in this design. Exam tip. Combine Fargate with EFS when containers need serverless compute and persistent shared files. Question number 360. A multiplayer game will run in several AWS regions and must accept both TCP and UDP traffic from global players. The design needs low latency, static global entry points, health-based regional failover, and no dependence on DNS cache expiration. Which two actions meet the requirements? Choose two. Option A. Deploy internal network load balancers in front of the application in every region. Option B. Deploy internet-facing application load balancers in every region. Option C. Create an AWS Global Accelerator with the regional load balancers as endpoints. Option D. Use Route 53 geolocation routing to direct all player traffic. E. Place CloudFront in front of the application to proxy the TCP and UDP sessions. The correct answer is A. Deploy internal network load balancers in front of the application in every region. C. Create an AWS Global Accelerator with the regional load balancers as endpoints. Here's why. NLB supports TCP and UDP. Global Accelerator exposes static anycast IP addresses, carries traffic over the AWS global network, and reroutes sessions to healthy regional endpoints without relying on DNS cache expiration. Why are the other options not correct? B. ALB supports HTTP and HTTPS application traffic, but not UDP listeners. D. Geolocation routing relies on DNS, and its failover behavior is affected by client DNS caching. E. CloudFront does not proxy arbitrary TCP and UDP application protocols. Exam tip. Use Global Accelerator with regional NLBs for low-latency global TCP and UDP failover. You have completed Part 10 of the SAA-C03 practice series. Continue your preparation by opening the complete playlist and watching the remaining parts in sequence. Please like this video, subscribe to Tech with Kaushik, and enable notifications for more certification exam preparation content. Share your score, questions, or feedback in the comments. Thank you for watching. See you in the next part.